If you all could remind me to hit record, that would be sweet, because that's like the one thing I'll forget. The one thing that I really want to emphasize to all of you is I don't expect that everything I said yesterday will stick. When we finish up like our first section in the class, I'll take you to where it is in the My Open Math that we need to go. And once the semester gets rolling, I'll be sending you weekly emails. Again, not to be a pain, but just so that we're all on track. So if anyone's missed anything, you know what the upcoming assignments are, when I've posted worksheets and that sort of thing. Okay. So one really important comment that I want to make is I'll announce it for sure tomorrow. Either okay, let me back up. So teaching is my thing, right? Like all my life, all I want to do is just talk about math, and it's kind of a joke that like I get to talk about my favorite subject. And one could say, well, what you get paid is kind of a joke too, but you can't put a price tag on loving your job, and that's really cool. But so being here and being present for all of you is like my number one thing. Having said that, I do serve on a lot of statewide committees. I'm running a statewide committee, and I do a lot of work in Helen to the office. And because I've got really strong opinions about how our students should be educated and how we need to do with our students. So anyway, I'm not quiet about it. So what that translates to is various times during the semester, I'm going to have to travel. On the days that I'm traveling, like there's going to be a couple of days at the end of September and a couple of days in November. What we're going to do is you'll know way in advance. I'm still going to hold class, but we're just going to Zoom it entirely. So I'm just going to skip out of the meetings that I have to go to because they're like 3-day long meetings and just Zoom class. So I don't cancel class in general because you pay a lot of money to be here, and I want to be present for you. But there will be a few days over the course of this semester that we will just Zoom class. And it works. Like I know how to do this from COVID times. When COVID hit in 2020, I was teaching a 400-person large lecture, and we managed. So like it's all cool. I just wanted to give you all a heads up about that. And then also this Friday, I have a retreat. I do a lot of work with the president and provost of that and author and I do a lot of work with them, and I have a morning long retreat with them. So I'll let you know tomorrow. It may be the case that one of my adjunct instructors comes and teaches the class on Friday here, or it may be the case that we just don't have class on Friday. But I will for sure let you know tomorrow, and I will send out an email. If Scott can do it, I just see him in here. He's totally cool. You guys will love. Okay, but that is the one that I have no way out. All right, so again, the one thing that I really want to emphasize is when I'm talking about the math, if something does not make sense to you, do not wait. Stop me and say, yo, Lauren, explain, or how did you get from here to here? Okay, like I know it's so easy to just kind of sit back and watch and be confused where you're confused, but don't let that happen. Okay, there's no reason why we can't all walk together in this course so that everybody has an understanding. And I understand that there's shyness that occurs, right? Like no one wants to be the one asking all the questions. But I will just think you're the coolest thing. Like I told one of you that yesterday. Yeah, because you asked a question. You totally broke the ice. It's awesome. So please stop me, okay? I'm not a mind reader, thank goodness. I need to know what's going on, but you know, but I really want to emphasize that you know, I know it's cliche, there's no such thing as stupid questions, but for goodness sake, you need to ask it. Okay, like this is genuine from my heart. Okay, that's number one. Number two, the other thing that I need to tell you is math is my thing. Learning names is not necessarily one of my strong suits. So I don't want anyone to take it personally, but I do want to get to know all of you as the semester progresses. You know, I can easily cheat on Zoom because I can say, oh, there's Hannah, right? I don't know what she looks like, but anyway, and so if we have time at the end of class today, I would love to have everybody just really briefly introduce themselves because it helps me. Okay, but you know, the more you come into my office, the more you interact with me. Several of you came and introduced yourselves to me yesterday. I love that. That really helps me out. I just don't want anyone to take it personally. Like we all have strengths and weaknesses and learning needs. It's not my strong suit. So, but it happens. Okay. Last but not least, if you are going to need to check out a calculator for this class, a bunch of Math 115 students over at the Mountain campus have been trying to come over here and check out calculators. And I want to give priority to anybody who is registered for a Missoula College class. So I know a bunch of you are Mountain campus students, but you're in a Missoula College offered math class. So you have priority to get a calculator. So if you're going to get a calculator to use this semester, I ask that you try to do that this week. Because if we have extras, for goodness sakes, there's no reason why we should just sit here. You know, I'm happy to have them for the Mountain campus sections, but it matters a lot to me to give the priority to those who are registered. Cool. Yeah.
So I ordered one and it's on its way. Would you recommend that I go get one downstairs until it comes?
I would recommend that you return it and get money back. Honestly, because you'll always be able to check out a calculator. I mean, if you want to, like, if you're going to be needing a calculator for whatever it is you're going to be studying,
yeah,
you know, maybe you do want to have your own calculator. But I'm just out to save you money.
cool. I appreciate that.
Yeah.
I've got a question.
Oh, awesome. Thanks. Does a graphing calculator work? Yes, you can totally use a graphing calculator. You don't need to use a graphing calculator. But if you have one, and it's like a TI-83 or a TI-84, you're just fine. You go check out the calculators. I love your questions, my friends. At the Missoula College Library. So it's in the basement of Missoula College. No, I've always wanted, I've been here for 20 years and I've always wanted to like form a free calculator checkout system to save people money. So this is like the really exciting thing. Okay. So if there are no further questions, I'm totally into starting the math. What I want to say as a preference to starting the math is that this is not a typical math. Okay. Number one, I believe I mentioned yesterday that you get a sheet of paper with notes on all of your tests. There are certain parameters which we'll talk about, but you know, my whole thing is that to me, memorization is not a form of learning. Because what do? You memorize things for the test and then you walk out the door and what happens? It's not. Are you really any better off? I don't really think so. What matters to me is that you learn how to think about these ideas and not worry about memorizing formulas, but rather know when and how to use them. Okay, so one of the things you're going to see is that, is this a math class or is this an English class? Because a lot of what I'm going to be doing is showing you how to translate. You know, people hate word problems, but word problems are what life is. Life is not handed to us in equations. But the ability to take a bunch of words and parse out what the relevant information is, ignore the irrelevant information, and then set up your problem, that's what we're really going to dive into. Okay. The whole point of this course is that hopefully what we're going to be talking about here is relevant and applicable to whatever it is your intended area of study. Okay, so we're, you know, those of you who are studying psychology and sociology and anthropology, for example, you're going to have to read studies and you're going to have to be able to look at data and understand what that data means. This is something that we're going to be talking about. Okay, those of you in business, especially toward the end of the semester, we're really going to look at a lot of programming and cost revenue profit and those sorts of things. But the way this class starts, I think of it as like a two-part class. The first part is all probability and statistics. And don't freak out. I go into this assuming that you can handle fractions, decimals, and percent, and that's about it. So I assume that we are at a very, you know, that we're all starting in the same place. We will get more algebraic. This is by no means anything like a college algebra class, but we will do more algebra sort of work later on in this semester. Okay. So, you ready?
Yes.
Okay.
Always.
Always. Okay. So I am going to share my screen and I am going to pin it. Yay. Now, thing that I'm totally bummed at myself about is I always write in purple. Purple's my color. Because purple is such a positive color, right? You know, grading in red, it's so judgmental. Green just kind of vibes me out. So anyway, but I forgot my purple pen. That's all to say. So we'll start out in a different color. Oh, you are so kind, but no, you can write in purple. Hey, are y'all psyched for a 3-day weekend? Don't worry, I'm always hip to days off. I know this. All right. Oh, this is so exciting. So, what we're going to be doing is, let me full screen. There, now you can probably see it a lot better. All right. So we are going to start this class and it's going to seem totally like, what are you doing, Lauren? This is supposed to be a math class. But we are going to talk about sets and counting. And what I'm going to let you know additionally is that at the end of class, I will be posting the recording of this class, as well as all of these notes that I write onto that box folder. That link is on our Moodle page. So in case, you know, some people have a hard time taking notes and listening at the same time. So this can help you. You will have all of these notes. So hopefully you'll take advantage of that in case that works and you can print them out or whatever. Okay, cool. All right, so that is what lesson 1 is all about, is sets and counting. Now, I'm going to start out by giving you a definition. So mathematicians like to define everything that we talk about because then there's no ambiguity. right? We all know exactly what I mean when I talk about a set, for example. Okay, having said that, you do not need to memorize any of these definitions. I give you these definitions so that we're all speaking the same language. And again, given the fact that you get a sheet of paper with notes, you know, this class isn't about memorization, it's about thinking, okay? So, again, I'm going to start by giving you a definition. It's just so that we're talking the same language. Okay, so don't think you need to make note cards to memorize things. Okay, so before we can talk about a set, let's all settle on what a set is. And I'm just going to say that a set is a collection of objects. Pretty deep, huh? Okay, now there's some specifications that we're going to be talking about with sets, and I will refine them. And but let me first give you a couple of examples. Sorry, there's some friends working at a coffee bar. Isn't that great? You get coffee right outside the door or tea. Okay. How about the set of people in Math 115, section B12? I don't mean to objectify us, right? Like I'm saying, it's a set of objects, but right, this does make a set. Okay. Now, at this point, this is all I'm going to say. I can't really list all the members of this set precisely because I told you I'm terrible with names, so I don't know everybody's names yet. Okay. Another set that we can talk about, which we will talk about, is, for example, the set of digits. Okay. That's a really important set that we're going to be referring to as we progress through this. Now, I could tell you that we're talking about the set of digits, but how do we know what the digits are? So there's two different ways that you can explain that. And one of them is literally listing all the members of the set. And the other one is you can use something called set builder notation. Now, we're not going to get really deep into these details, but there's certain notation that we use, and I want us all to be on the same page, okay? So, for example, if I want to talk about the set of digits, a couple things that I want to say. We like to name our sets. When we name sets, we name them with capital letters, okay? I'm not an original person, so, for example, I'm going to call my set of digits capital D. Okay, you can call it anything you want. Okay, but we always name them with some capital letter. And if I'm going to list the members, you make a curly brace. Doesn't have to be fancy. You can just go. Okay, and I'm going to list my set of digits. So in case you did not know what all the digits were, there you have them. Notice there's 10 digits, 0 through 9. Okay, this is something that we're going to refer to. This is a pretty common set. So you do want to be aware of what the set of digits are. Okay, so it's the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I can be kind of a lazy person. Imagine that. So another way that I could write this, if I was like, oh my gosh, my arm is so tired and I don't feel like writing anymore, is I could say 0, 1, 2, okay, you get the point, and it stops at 9. Okay, this is equivalent. This assumes that you kind of catch the vibe of the pattern and you know it ends at 9. Okay, this is what we mean when we talk about listing the members of the set. Now, there's also something called set builder notation, and I'm only mentioning this because for those of you who read in the book, you're going to see it, and I want you to understand what it is you're looking at. I'm not going to test you on, can you write a set in set builder notation? It's not where we're at, okay?
But what set builder notation looks like, and this is still my set D, it's the set of all X such that X is a digit. And I will write out exactly what I mean there, or exactly what I wrote. So that's read as the set, and you don't have to write this down if you don't want to, of all X such that X is a digit. Now, this set builder notation is, it's kind of sweet in the sense that if you have a humongous set, there's no way you're going to want to list all the elements, right? Or if I wanted to talk about the set of all the people in this room, I don't know everybody's name. So that would be a really sweet way of doing it. But would you grant me, if you didn't know what the digits were to begin with, that this would totally not be helpful? Right? Like if you didn't know that the digits were the numerals from 0 to 9, would this be helpful at all explaining what it is? No. So there's advantages and disadvantages with each of those notations. Okay. But you're going to be seeing sets, and the important thing is that you know how to identify them. Now, one set in particular that we really like to talk about is the empty set. You haven't noticed, we start out this class really chill. You don't just dive or anything. Really deep now. It's a nice way to ease into the semester, isn't it? I think so too. All right. So, as you might assume, the empty set is the set that doesn't have anything in it. Okay. So the way we show the empty set is we could put curly braces with nothing inside. Another common way to represent the empty set is using this null symbol. Yes? Because what we're going to be doing, that's a great question, is we're going to be doing set operations. We're going to be looking at combining sets, looking at complements of sets, and the empty set comes up. That's a beautiful question. Thanks. The thing that I want to note to all of you is this is not the empty set. You know why? Kind of, sort of, yeah. I claim that this is a set that has one element in it. And the one element, remember, of the set is the empty set symbol. Okay. In other words, use this, don't use this. Okay. All right. So I've already sort of used some of these words, but I want to formalize this. So I'm going to rewrite my set of digits. And what I want to tell you, and again, I'm just giving you definitions a lot today. We'll dive in deeper, of course, tomorrow. When we talk about the members of a set, they're called elements. It's a word that you're going to see. It's a word that I'm going to use. And so I want to make sure that I define it. Okay. Now, what if I ask you the following question? And this is not a trick question. And by the way, when I pose questions in here, please participate. If you're wrong, it doesn't matter. Like, I'm just thankful that this is an interactive environment. Okay. So what if I ask you, is 5 an element of D? What are you going to say to me? Yeah, totally, right? Yes. Well, my goodness gracious. One of the other characteristics Oh, thank you for chatting. I love that. Brianna. Another characteristic of mathematicians is we are kind of lazy creatures in the sense that like, you don't have to write more than we really need to. So it's a lot of work to write 5 is an element of D. So what we do is we use notation, okay? So the way that we're going to indicate that 5 is an element of D is you write 5, and it's kind of like an epsilon or a funky E, but that means is an element of. Okay, we don't use notation to make things confusing. We use notation simply because we're lazy or efficient, depending on how you want it. So let me ask you another question. Is 11 an element of D? No way. Right? We don't have the number 11 in here. So how do you think we're going to indicate notation wise that 11 is not an element of D? Totally. The way we do it is like the way we say that things are not equal, we put that slash through it. That means is not an element of. Okay, again, this isn't stuff you have to memorize, but it's notation that you're going to see, and I want you all to understand what you're looking at. All right. So something that might seem sort of like, okay, and so what? But it's important for me to state that 2 sets are equal if they contain the same elements. And if you're like, and I had to come to college to be told this, I understand your thoughts. But the point that I'm trying to make is, suppose I just randomly define my set A to be 1, 2, 3, 4. And I define my set B to be 2, 4, 3, 1. A is equal to B. And the point that I'm trying to make is that the order the elements are listed in doesn't matter. These 2 sets contain the same elements, therefore they're equal. So it's very different than like order. For example, when you stop. Nope, not the same. They have to be the same elements. Then you would say the number of elements in A is equal to the number of elements in this other set. But the sets themselves are not equal. And that is beautiful because we're actually going to be starting to talk about the number of elements in a set. That's very relevant. All right, just a couple other things that I want to put out there. Suppose I say, let's have my set A be 1, 2, 3, 4. And I'm going to define a set C to just be 1, 2, and 3. Again, this is just a lot of like background stuff. We haven't really gotten to any of the math. Okay. You might ask, where did those sets come from? Because I just totally made them up. Okay. Would you grant me that every element in C is also in A? Okay, right? Everybody in here also happens to live right here. Cool. Isn't it great when we can agree on things? Okay, well, when that is the case, we say that C is a subset of A. And the way that's written is this. So it's kind of got like a sideways horseshoe with a line underneath. Okay, can I ask you a question? Other than the one I just asked? Is A a subset of C? No, how come? Who blows it for A to be a subset of C? 4. Right? 4 is in A, but 4 is not in C. And again, I'm just writing this out so that you're starting to get acclimated to the notation that we're using. Y'all with me this far? Are you thrilled? Like, yeah, I get to wake up and talk about sets and subsets. All right. So one slight comment that I want to make is any set is a subset of itself. Okay, so any set is a subset of itself. And by default, the empty set is a subset of any set. Right? Is every element in the empty set in A? By default, kind of, right? Because there's nobody in here. Okay, so these are just kind of 2 side notes. Is this pace okay so far? Yes.
Can you just say that last thing?
This, the empty set is by default. Thank you. Of every set. Oh, great minds think alike. And I really appreciate your questions. This is we're gonna have a ball this semester. Okay. Okay, cool. So what I'm about to say is as follows. You don't need to write this down, okay? I'm making a distinction that if you read the book, and notice I always say if you read the book, because I'm very cognizant that a lot of people don't really like to read math books. But if you read the book, you're going to see some notation. And I just want to make it clear to you, this is nothing that we're going to be getting into in this class. But I do want to bring it out. Okay, so what I'm saying is you don't need to write this down, but I'm trying to just show you some notation that if you really start reading in the book, you'll see. And I don't want it to vibe you out. Okay, so do you agree 5 is less than 7? Yeah, isn't it great that we can agree on things? Do you agree that 5 is less than or equal to 7? Oh, it totally is. Right? Notice it's less than or equal to. So it's one or the other. So this totally holds. Okay. I love whoever said no, because there is a huge distinction. And I was hoping somebody would say that. Okay. These are called inequalities, as you know, or as you learned sometime in your life. This, technically speaking, I don't mind you guys talk, just totally whisper. There's a distinction between these 2 inequalities. This is called a proper inequality, and this is just called a straight up inequality. This is a proper inequality because this does not allow for equality, right? So for example, I could say 7 is less than or equal to 7. Sure isn't less than, but we got the equal to, but it's not correct to say that. Okay. So when some people study subsets of sets, they make a distinction between what's called a proper subset versus just a plain old subset. Like A is a subset of A. Not because A is exclusively contained in A, but because A is equal to A. It's not correct to write it like this. Okay. This means a proper subset. So like using our sets before 1, 2, 3, 4 and C equaling 1, 2, and 3. I could say that C is a subset of A like this, or I could say C is a proper subset of A. Kind of like I could say that 5 is less than 7, and I could say that 5 is less than or equal to 7. Either one of these are okay. This thing means that equality can happen. This is nothing we're going to get into. There are some Math 115 courses that do really get into the difference between these. It's not where we're going to go, but it's an important distinction that I want to make. And the reason why I brought up these inequalities is this is something that you've looked at some point in your life and have made the distinction between. Okay. All right. So don't sweat it. Okay. Just be aware. Now, next thing that I'm going to talk about are Venn diagrams. Venn diagrams are used to represent relationships between sets. Not only that, but they're a really handy way to sort information. And count things. Now, I would venture to say that there's probably a certain cohort in this room who dealt with Venn diagrams before, but I would also venture to say that there's probably some people who've never dealt with them. Whenever I'm introducing a new concept, I introduce the concept as if you have no idea. So I am making no assumptions on your familiarity with these. I want us all to walk together. Okay, that's very important to me. Okay. But this is really fun stuff. And this is what we're going to be talking about today and also tomorrow. But before we get really into if everyone on Zoom mute. A little background music. Okay. I love it. Yeah, whoever was playing that was beautiful. Oh, no problem at all. I kind of like that. And sometimes when there's musical interludes at perfect times, it's great. Okay. No, I think it's great. Thank you. You have to add lightness to me, don't you? Yeah. All about it. Okay, so what I'm going to do before we get into these Venn diagrams is I need to tell you what the universal set is. And fortunately, it's exactly what you would hope or intuit it would be. It's the set of all elements. But it's the set of all elements of interest. but it needs to be defined by context. I will never expect you to know what the universal set is. Okay, and let me explain in a moment. I want to give you a chance to write. If I'm talking about the set of digits, okay, that's a collection of those 10 numerals. Okay, if I'm talking about the set of digits, it makes sense for my universal set to perhaps be all real numbers, right? That's a big one, or all complex numbers, even more so. But if I'm talking about the set of people in this room right now in Math 115, it makes no sense to have my universal set be the set of real numbers. In that case, I would need to have my universal set be the set of all students at the University of Montana School College, right? So your universal set is by context, and it depends upon what you're talking about, but it will always be provided for you, okay? But what you want to think about is the universal set is just everything. Cool? Okay. So the way we write the universal set is this is a cursive U. I like to define what I'm writing because my handwriting isn't always terrific. Okay, so when I'm talking about the universal set, it's a cursive U. Okay. What I'm going to do right now is I'm going to draw a picture of a Venn diagram, like a little tongue twister. And I'm just going to point out various regions. What I'm going to point out to you is super important, okay? Because I want you to get a feel for it, okay? So I'll do this and then we'll be at a really sweet little stopping place for today. And then what I'm going to do is start out class tomorrow by drawing a bigger Venn diagram and we'll analyze it, okay? We're not going to get bigger than 3 circle Venn diagrams, but most often we're going to hang out in 2 circle Venn diagrams. All right, so math can get philosophical, okay? This box is my universe, okay? Right? Like we can think of it, don't we like put ourselves sometimes, unfortunately, into a little box in our lives, and it's like, well, this is everything, and then we say, "Think outside the box." We are, but we're in good company. Yeah. Okay, so when we're drawing a Venn diagram, the box is our universe. Okay. Now I'm going to have a couple of sets in here. And again, I'm not original at all. I'm going to have this circle be my set A. And I'm going to have this circle be my set B. And again, I want you to pay particular attention to the words I use. You know, when you're a kid growing up, what's the magic word? It's supposed to be please, right? Not in this class. It's or, and if. Those are our magic words, okay? So what I want to say is as follows. Everything in this circle is in my set A, okay? But there's 2 different regions to that. Would you grant me that? This stuff in this portion of the circle is only in A. This stuff on the overlap, would you grant me that this is in A and in B? So this is in A and in B. And is a big word. What about this stuff right here? That's only in B. How about this? Is this stuff in my universe? Totally. It's in my box, but it's not in A or in B. So it's stuff in my universe, but just not in either one of those two particular sets that I have. And I know, again, that it seems silly that we're taking the time and talking about this verbiage, but this is going to help you when you get into word problems and have to start parsing these out. Are there any questions on this? All right, so technically there's 2 minutes left. So what I'm going to say for about 30 seconds of them is as follows. Number one, thank you for all your questions. I love it. Number two, if you have not already enrolled in the My Open Math, please do it. And number three, I hope you have an awesome day. Thanks. I will try my hardest.
So are we like, let's go over where the supplies and like problems. Problems.